and welcome to the Chemistry Solution. This tutorial is on determining the names and formulas of compounds, and this includes both ionic and covalent compounds and how to tell the difference. Now, this tutorial doesn't go into as much detail as far as explaining the rules as to how to determine names and formulas for ionic compounds or covalent compounds. I've done other tutorials that explain these rules in more detail. This tutorial is mainly just on examples. Now, the reason I've mixed ionic and covalent compounds together here is because normally when most students learn naming rules, they learn the naming rules for all different types of compounds. So I thought we'd put these all together and go through and practice determining formulas and practice naming for both ionic and covalent compounds if you have examples that are all mixed together. Okay, let's look at our first example. The first thing that you need to determine when you're looking at a formula is whether you have an ionic compound or a covalent compound. Now, there are exceptions to this, but a good rule of thumb is, in general, ionic compounds are a metal and a nonmetal. You're looking at elements from two different sides of your periodic table. Covalent compounds are typically two nonmetals, and these elements are located on the same side of your periodic table. So this rule works for most examples. Okay, so if I look at NaF, sodium fluoride, I know that sodium is a metal, fluorine is not a metal. This must be an ionic compound. So I need to name this compound following ionic compound naming rules. And that is the cation keeps its name, so sodium, and the ending of the anion gets changed to ide. So the name for this compound would be sodium fluoride. Remember, the biggest difference in naming rules between ionic and covalent compounds is that in an ionic compound, it doesn't matter how many of each type of element you have. And in a covalent compound, you need to indicate the relative numbers in your formula. Okay, moving on to example 2, N2O5. Nitrogen and oxygen are both nonmetals. This is a covalent compound, and so when I name it, I need to use prefixes to specify the number of the different types of atoms that I have in my compound. So this compound we would call dinitrogen pentoxide. Looking at the third example, I have barium, which is a metal, and then I have this nitrate group, which is a polyatomic anion. So the name of this compound will be barium nitrate. Now, another thing to remember is that for the most part, if you're just taking a high school chemistry class or an introductory level college chemistry class, you're only expected to know how to name binary molecular compounds or binary covalent compounds, binary meaning two elements. So if you see more than two elements in a compound, you can usually assume that that is an ionic compound as well. So looking at my fourth example, CuCO3, I have copper. Because I have a metal, I also must know that this is an ionic compound. And because I have more than two elements, I know this isn't just a simple binary ionic compound. I know I must have a polyatomic ion in my formula. So CO3 with a charge of -2, which you obviously don't see in the final formula, is the polyatomic ion carbonate. So because CO3 has a charge of -2, the copper ion in this formula must have a charge of +2. And remember, because copper is a transition metal, I need to include the charge of that ion in my name as a Roman numeral. So the name of this compound would be copper 2 carbonate. Last example on this page, I have carbon and chlorine. Both of those are nonmetals, so I need to use my prefixes in my name. This would be carbon tetrachloride. Remember, when you're naming covalent compounds, everything gets a prefix unless there is only one atom of your first element. Okay, let's look at some more examples. C and O, copper and oxygen, are both nonmetals. This must be a covalent compound. The name of this is carbon monoxide. So again, everything gets a prefix unless it's the first element and there's only one of them. So because carbon is the first element in this formula and there's only one carbon atom, it does not need a prefix, but I do need to distinguish that there's only one oxygen atom in this formula using that prefix mono. pH 3, both phosphorus and hydrogen are nonmetals. So again, I'll use my prefixes, phosphorus trihydride. MgSO4, I know that magnesium is a metal. This must be an ionic compound. And because I have two additional elements with magnesium, I know that I have a polyatomic ion in my formula. So the name of this compound would be magnesium sulfate. Again, remember that polyatomic ions always get to keep their own names. You never have to change or modify them. AgCl, silver is a metal, chlorine's a nonmetal. This is an ionic compound. Silver is a transition metal, but it usually only forms ions with a charge of +1, so we don't have to write that as a Roman numeral in the name. This is going to be silver chloride. So if you have an ionic compound that's just two elements, a binary ionic compound, remember the cation keeps its name. The ending of the anion gets changed to "ide." This last compound you probably all recognize as water. If you wanted to give it a name using the appropriate covalent naming prefixes, we would call this dihydrogen monoxide. Okay, let's work backwards. Tetraphosphorus trisulfide. Determining the formulas for covalent compounds is usually quite a bit easier because the prefixes tell you exactly how many of each atom you have. So tetra means 4, we have 4 phosphorus atoms, and tri means 3, so 3 sulfur atoms. P4S3. Gallium arsenide. Gallium can be considered a metal, and arsenic is a nonmetal. Gallium forms ions with a charge of +3. Arsenic forms ions with a charge of -3, so the formula here would be GaAs, because the +3 charge on the cation will cancel with the -3 charge on the anion. Okay, third example, dinitrogen tetroxide. Again, because you see those prefixes here, we know exactly of how many of each atom we need. So 2 nitrogen, 4 oxygen, N2O4. Iodine trichloride. Again, you see that prefix. So we know that we must have 1 iodine because it doesn't have a prefix, and 3 chlorine because of that tri, so ICl3. And silver chlorate. Silver is a metal, and I know that it forms ions with a charge of +1. Chlorate, I see that 8 ending, so I know I must have a polyatomic ion, and in this case the polyatomic ion is ClO3 with a charge of -1. So the formula would be AgClO3. Okay, let's do just a few more examples here. Hopefully you're all getting the hang of it. Dinitrogen monoxide, again prefixes, so you're told exactly. This is a covalent compound. N2O. Sulfur hexafluoride, again 2 nonmetals, covalent compound. You see the prefixes in the name. SF6. Ammonium carbonate. This is one example where you have an ionic compound that doesn't actually have any metals in it. Remember, ammonium is one of the few positive polyatomic ions, and anytime you're putting 2 ions together, you have an ionic compound. So ammonium is NH4 with a charge of +1. Carbonate, that's another polyatomic ion. Here we have a polyatomic anion. Carbonate is CO3 with a charge of -2. That means you're going to need 2 ammonium groups, each with a charge of +1, to balance that negative charge on the carbonate polyatomic ion. So your formula will be NH4 in parentheses with a 2 outside of parentheses, CO3. Again, remember, anytime you have more than one of a polyatomic ion, put that formula for the polyatomic ion in parentheses. Calcium hydroxide. Calcium I know is a metal. Hydroxide, remember this is a tricky one. Hydroxide is the polyatomic ion OH with a charge of -1. So you see that "ide" ending and the hydro in front, and people want to think it's a hydrogen ion. That's not the case. OH -1 is the formula for hydroxide. Calcium forms ions with a charge of +2, And those hydroxide ions, I just told you, have a charge of -1. So that means I need 2 hydroxide ions for every 1 calcium to make that compound neutral. Again, make sure anytime you have more than 1 polyatomic ion, you put that formula in parentheses with the number that you want to indicate of that polyatomic ion outside of parentheses. So CaOH in parentheses 2. Okay, last example, lead 2 chloride. Lead is a metal. That 2 in parentheses indicates that lead has a charge of +2. Chloride, that's the chlorine ion. Chlorine forms ions with a charge of -1. So my formula here is going to be PbCl2. Thanks for watching the chemistry solution. I hope those examples were helpful. If there are any other topics you would like to see tutorials on, please feel free to email me at Missy, that's MISSY, @thechemistrysolution.com. Thanks.